but للأسف يعني we don't have that luxury. Yeah, I understand. But المشكلة ما فيش أصلا مجال خلص أكثر من لا في نفس السيشن. طيب anyway, but and then in Ramadan inshallah, I'm pretty sure they did not announce it yet, but I'm pretty sure in Ramadan they will make the break half an hour, just like last year. I think so.
Are they?
So if the break is half an hour, so that means that all labs are going to end at 4:30, not at 5. So that's the only thing that they change. Again, that's not really helping. I know. Yeah, and then classes that start at 9 still start at 9. Still, yeah, they don't really make any changes in Ramadan other than, making the break shorter. What is it? بالضبط كل سنة نفس المشكلة، كل سنة كلهم نفس المشكلة. طيب هو انتوا على الأقل قاعدين، احنا نقعد نبرد 3 ساعات وربع. Alright everyone, yeah. So chapter 6, methods. Methods is just another name for a function. That's it. A method, a function, the same thing. إذن تدور. يلا. طيب. Look at this problem here. Find the sum of integers from 1 to 10, from 20 to 30, and then from 35 to 45 respectively. Alright? Now, if we don't know about methods, if we don't know how to create our own methods, we can basically, to solve this kind of problem, we can repeat the code. صح ولا لا? One loop is from 1 to 10, another loop is from 20 to 30, and then the third loop is from 35 to 45. But then the code is very similar to each other, right? It's very similar. So how can we fix this so that we don't repeat the code over and over again? How can we fix this? Again, you create a method for this to calculate the sum basically. You pass whatever numbers you want to calculate the sum for to that method, and that's it. You do not need to rewrite very similar code. You see here, the only difference is where it starts, where it ends. That's it. That's the only difference. Otherwise, it's exactly the same. So here we go. How can we do it? We can simply create a method for it. Let's look at this. Now, so far we don't know at this point yet. We don't know what public and static means. Okay? We will keep them. So when you create a method, number one, you cannot create a method inside another method. No, of course not. So this is the main method, you create a method outside it, of course. When you create a method, what do? You put the header for the method. We do not have something called the define keyword here, just like in Python. No. Here you go, you create the main method, you put the header, خلاص هذه صارت method. That's it. The same thing for any other method that you create. So you start with you put the header. What do you put in the header? Public and static, these are called modifiers. What do they mean? We don't really care what they mean right now. Okay, so let's keep them. Later on we'll understand there is public, there is private, there is other stuff. We can put static, or we cannot, or sometimes we don't put static. They mean, when we learn inshallah about object-oriented design, we will go back to this part. So for now, public and static stay. Then you put the return type. What does this method return? What is the type of the value that this method returns? What is the type of the value that this method returns? Int. Very good. Now the return type can be anything. It can be int, double, string. It can be any type of object. Inshallah we will learn about arrays. It can be anything. Type. Then the name of the method. There it is. The name of the method always, just like a variable, starts with a small letter. Unlike a variable, method names are always verbs. We use nouns for variables, we use verbs for methods. Then, between parentheses, you put the parameters. Maybe the method has 1 parameter, maybe it has 10 parameters, maybe it has nothing. And, when you put the parameters, what do? Again, in Java, you always need to specify the type, always. So, when you put the parameter, you put the type of the parameter first, then the name. Type, name, etc. Or maybe it doesn't accept any. Then you open brace, you close brace, inside it, this is where you put your code for the method. So this method here has two parameters. What does it do with it? Int sum is 0 for int I is I1, whatever value it receives here. I is less than or equal I2, whatever value it receives here. I plus plus, sum plus a sum operator I. What is it doing? Yeah, what is it doing? What is this method doing? Calculating the sum. From where to where? Excellent. From I1 till I2. At the end, if not necessarily even at the end, عادي ممكن in the middle sometimes. Then, if the method returns a specific type, like int here for example, you need to see a return statement here. The return statement returns the same type as the return type here in the header. So return sum, this sum should be an int value. طيب, if it doesn't return anything, what do we put? Void, excellent. It's like the main method, public static void. The main method does not return anything. No return statement means you have to put void here. And that's basically it. What is it? It's void instead of the return type. So if it doesn't return anything, you put void here. Leave. Huh? Yes. You have to put the return type. So again, public وstatic والreturn كله هذا ثابت. Public static. لا compile it will not let you run. طيب, how can we use it now? You call it. You call it from anywhere in the code. Here we call it from the main method. System.out.println sum from 1 to 10 is plus, here we go. This is a method called sum 1 till 10. When we reach this point, we will jump to the sum method. The sum method receives 1 in I1, 10 in I2, execute, and returns the sum. Sum 20 to 30, sum 35 to 45. There we go. Okay? Questions so far? Questions? Fine. So a method is a collection of statements that are grouped together to perform an operation. Here we go. This is the method header. Public and static are what we call modifiers. They stay for now until inshallah we learn what they mean later on. Then we have the return type. Then the method name. Between parentheses you put the parameters. The parameters again, you put the type of the parameter, then the name, comma, type name, like that. Type. Now, the method name along with its parameters, so this part here is called what is called the method signature. What is called? Method signature. So when I say the method signature, what do I mean? I mean the name of the method along with the parameter list. Okay? This is the body of the method, and here this is the return value. Like when you call it something like this. Say the name here is Max. Max, and then you pass X and Y to Max. These are called arguments, or what we call actual parameters. Like the parameter list itself, we call them formal parameters. Right? So the values that you pass are called arguments, we know that, or actual parameters. The parameter list here in the method header, what do we call them? Formal parameters, or parameters in general. So this is the method signature, method name and the parameter list. Formal parameters, these are the formal parameters. The variables defined in the method header are known as formal parameters. When a method is invoked, it's called, you pass a value to the parameter. This value is referred to as actual parameter or argument. Then here we have the return type. A method may return a value, may. The return value type is the data type of the value of the method, of the value the method returns. If the method does not return a value, a return value type is the keyword mean void. For example, the return value type in the main method is void. Yeah, let's look at this very simple example. So testing the max method. So this is the max method. By the way, the return type and then the type of the parameters do not have anything to do with each other. Understand that, yeah? Do not create patterns in your head that do not exist. It's just a coincidence that this method received int and returned an int. عادي. Can receive strings and return a double. It can receive one double, 3 int, and return a string. Doesn't matter. There is no correlation. Correlation. There you go. Between the two things. Right. Testing the max method now. Yeah. Let's look at this. There you go. Alright. This is my class, test max. I have the main method here, and then I have, see, another method. There you go, which is max. Java always knows that it should start executing from the main method. So from the main method, yeah, int I is 5, int j is 2. Int k is max of I and j. What do we do here? We call the max method. What do we pass? Which are 5 and 2. So here we go. We jump to the max method, receive I, which is 5 in num1 and 2 in num2. Yeah, int result, if num1, if 5 is greater than 2, result is 5, else result is 2. Return result. Or, straightforward, you can say, if num1 is greater than num2, على طول, return num1, straight away. No need for this. Else, return num2. Why? Because we know, again, since the Python days, in a method or in a function, as soon as you reach a return statement, you exit. You exit the method. So there is no even need here for this result variable. Right? You can say straight away if num1 is greater than num2, or return num1. خلاص. As soon as we get to a return statement, we exit the method. Right, so k is going to take which value? 5. There you go, 5. Finally, the maximum between 5 and 2 is 5. Questions here? Questions? Alright. So this is exactly what we did just now. We get to this part, we call the max method. The max method receives the arguments with its parameters, executes, and then returns the result. Right. So here we go. I here is 5, j is 2, invoke max I and j. Here we jump to max, pass the value of I to num1, pass the value of j to num2, and do the whole thing here inside, and then finally return the result, which is 5. 5 goes back to where this method was called from, and then in this case it is assigned to k. Right. Caution. A return statement is required for a value returning method. Yes, you can't put int here and there is no return statement. Can't. The method shown below in A is logically correct, but it has a compilation error. Why? Look at this. Look at this. Public static int side int n. Like, if n is greater than 0, return 1. Else, if n double equals 0, return 0. Else, if n is less than 0, return minus 1. The compiler does not accept this method. Why? Why do you think so? Is it? Why doesn't it give us this? Why doesn't it accept it? Because again, the compiler doesn't do the computations, doesn't look at the actual numbers, يعني, before runtime. Now, it looks at the method. It says here, if this is false, and this is false, and also this is false, there's no return statement. You understand what I'm saying? So here the compiler, again, we know that yes, if it's not greater than 0, and it's not double equal 0, it's definitely less than 0, correct? Huh? But the compiler doesn't do the computation, doesn't look at the actual numbers. Now, the compiler here says, if all of these are false, or if this is false, and this is false, and also this is false, we will not reach a return statement. Since we will not reach a return statement, the compiler does not accept this. It does not accept this. But how can we fix this? Else, very good. Why do you have this extra condition here? خلاص خليها else. When it's only else, the compiler knows, okay, if this is false and this is false, خلاص, this is definitely true. So we'll definitely reach a return statement at the end of the day. Alright? So how can we fix this? Remove this. It's actually a logical error. Why? Why are you putting an extra condition here? Even if the compiler accepts it, yeah? Even if we assume that the compiler accepts it, why are you putting this? If it's not greater than 0, it's not equal to 0, it's definitely less than 0. So why are you checking again? So how do you do this? You do it this way. Here you go. You remove this extra condition. Now, if this is false and also this is false, no problem. This will definitely be true. meaning we will definitely reach a return statement in any case in this method. Right. So to fix this problem, delete the last condition here, so that the compiler will see, here we go, will see a return statement to be reached regardless of how the if statement is evaluated. Right. Reusing methods from other classes. You can create a class, add it, just like we usually do, and then in another class, you can create a class, put your methods there, and then in another class, call the methods from that class, from the class that you just created. How? No need for import if they are in the same package. Don't worry about the import for now. Don't worry about the import. Okay, so we did not learn about the import yet. We only learned about the import from the Java library. Again, but if the classes are in the same, basically, folder, you don't need the import statement. Right, how can I call it? Huh? So using the method name straight away? Because it's in the other class. How will the compiler know where is the method? Class name, very good. Use the class name. Use the class name. So, one of the benefits of methods is for reuse. This is actually one of the most important benefits. The max method can be invoked from any class besides the class where this method is found, test max. If you create a new class test, for example, you can call the max method from the test max class. How? Test max dot, there you go, test max dot max. So if you create a new class test, you can invoke the max method using class name dot method name. So test max dot max. Okay? But later on, inshallah, we will learn that if the method is not static, we cannot do this. But now, since we know that all methods are public and static, we can do this. Later on, we will learn that if the method doesn't have the static keyword in its header, we cannot call it using the class name. We actually need to create an object. Alright. Call stacks. Like, what really happens when methods are being called in Java? Not only in Java, and this happens in every programming language. Like, Abdullah, on the table, quickly. Quickly. Right. So every time a method is called, every time a method is being executed, what we call an activation record is created for that method in the memory. What's an activation record? Basically, a specific space that is reserved for the method in memory. Okay? In that space, we will store the values for the variables, if it calls any other methods. Like. Now we know that Java always starts executing from where? Higher on, where does Java start executing? From which method? Main method. Yes, and where does Java start executing from? The main method. Turn to أنا قاعدين نسوي ركز معي. Razan, where does Java start executing from? The main. So the main method starts executing without having to call it. Yani in Python we had to call the main method. Remember, we had to call it at the end of the code. But in Java we didn't have to. Right. So the main method starts executing. Meaning an activation record is created for the main method in memory. So where is it exactly? Where does it put? It's put in a structure called a stack. Inshallah, when you learn about data structures, you will learn about stacks. What happens? The activation record is pushed into the stack. Then, here we go. This is the main method from just before. The main method has the variables I, it has the value 5, K, J, 2, and then K. If you remember, here it is. This is the code. So I is 5, so the activation method for main, push into the stack. This is what we call the call stack in memory. Like, what do we put in there? I is 5, J is 2, declare k, but we don't know the value of k yet. What is the value of k? Another method call. Alright, we have another method call. Another activation record is created for the new method, which is max in this case. Yeah, create the activation record, put it into the stack. Why do we do this? Why do we put them in stacks? Because stacks work last in, first out. This is what a stack means. Last in, first out. So when you create an activation record for the max method, you put it inside the stack. You go ahead and execute the max method first. So later on, when you are done with the max method, it is popped, that's what we say. Push, pop. It is popped out of the stack, means we are done with the max method. What's underneath it? Main, meaning go back to main. This is how the Java virtual machine keeps track of all of the methods that are being called. And how does Java virtual machine keep track of the methods that are being called? Okay, this one calls this one, and this one calls this one. Add 10 methods calling each other. How does it keep track with the call stack? Every time a new method is created, they'll create activation record, put it in the stack. When you are done with it, pop it from the stack. And then what's underneath it? The method that just called it. Okay, go back to that, continue execution. This is how it keeps track of how methods are calling each other. Right, so an activation record is created for max. Here you go. Push it into that call stack. Max receives the value, which is 5 in its variable num1 and 2 in num2. It executes and then it returns the result which is 5. 5 is then returned to the previous, to k, from the main method. Like what happens to the activation record for the max method is popped. Now خلاص, we are done with the max method, done. To go back to the previous method, pop this out of the call stack. It's popped, it's moved, خلاص, bye-bye, max method. We are done, it's not going to use any more space in memory. It is. Who called this method the main method? Yalla, go back to the main method, continue executing. So 5 now is returned here, assigned to k, and we have one more statement to execute. The one more statement is actually a call to another method, and here println method. So if we want to get technical here, another activation record is then created for the println method. Println method is in the Java library. You jump there, you execute, and you come back here. Okay? And that's it. This is what a call stack means. So call stacks means it's a structure, it's a way of how the Java virtual machine, not only the Java virtual machine, every programming language really, keeps track of all of the methods that are being called. Like void method, this type of method does not return a value. Let's look at this. Just void method. Yeah. There we go. We have the main method and then we have print grade. See? What is the return type of print grade here? Void. Very good. It receives only double. Type. System the grade is print grade 78.5. Jump to print grade, receive 78.5 and score. Do this. If score 78.5, it's here. 78 here. System println C. Halas. That's it. No return, no nothing. Go back. Continue. The grade is again another call. 59.5. Receives it here. 59.5 F. And then go back. No more code. We're done. Okay? A void method does not have a return statement. Questions? Yes, go
We
ahead.
don't need to put the main.
Huh?
We don't need to put main.
What do you mean?
So main method.
This is the main method. What are you talking about?
It's the first one.
Adi B. Adi B.
Oh, okay.
Yeah?
I just saw it.
Yeah?
Where do we use it if it's not going to return anything?
Okay. Later on, inshallah, when we learn about object-oriented design, you will see that a lot of methods that are void are used to manipulate global variables. We'll see later on, inshallah. They are used to change them, yes. They are used to change their value. Global variables later on. So global variables are variables that are created outside methods. Inside the class, but outside the methods. So we use void methods usually to print something like this, usually most of the time, or to manipulate global variables. Because if you are manipulating the variable, why do you need the return type? You understand what I'm saying? Yeah? And then we will also learn that global variables are called attributes. But this one later. So void methods, usually printing or manipulating global variables. طيب, passing parameters. Alright, let's look at this example. So public static void, here you go, does it return anything? What is the name of the method? And print. Receives what? String message and then int n. Very well. For int I is 0, I is less than n. What does this do? Prints message how many times? N times. Very good, very good. So this prints message n times. Like, suppose you invoke the method using println welcome to Java 5. What is the output? Yeah? What is the output? Welcome to Java 5 times in 5 separate lines. What about this one? Computer science 15 times. And what about this one? Can we do this? Can we do this? Now, when you are calling a method and you are passing arguments, the arguments need to match the parameters in order. Okay, so you cannot do something like this. This will not let you run actually the code. Okay? When you are calling a method, passing arguments, the types of the arguments need to match the parameters that are seen. Yeah, here they are switched, you can see. Let me zoom in. There you go, they are switched. So if I 15 first, then the 3 first. This one? Yeah. Yeah, of course, that's fine. Yeah? They should match. They should match. Like, pass by value. We have seen this in Python as well. Remember if I pass a value to a method and then I change it in that method, does it change in the original method? No. Remember when we said this in Python as well? Methods do not have access to each other's variables. Remember that? As long as the variables are primitive data types, if it's an object, then it's a different type. Let's look at this. So this program demonstrates passing values to the methods. Look at this. This is what we call pass by value. Type. So here we go. Public class increment. I have the main method and I have the method increment. Type. Index is 1. So before the call, x is what? 1. Increment x, increment, and then pass 1 to it. We go to increment, it receives 1 in n. Fine. N plus plus. What is n now? 2. N inside the method is what? 2. Go back here now. Just after the call, x is what? 1. There we go. There we go. If I change it here, it does not change up here. Again, methods do not have access to each other's variables as long as they are primitive data type. If they are objects, then they can kind of change each other's variables. But we will inshallah learn more about that when we get to the object-oriented one. So, what I need you to understand now, I put this in because this will help us later on. If you are using primitive data types, what do I mean by primitive data types? Talking about the 8 types that we have seen so far, and also strings, because strings are immutable. Anyway, so if you are using any of the 8 data types and also strings between methods, a method can never change a value of a primitive type of another method. Never. It can never. Like this. I put it here, change it here, it doesn't change back here. Okay? Inshallah, when we create objects, when we learn about objects, when we create them, you will see that yes, methods can change the object sometimes. So it depends. It depends. So now keep it in your mind that I don't want to generalize this, okay? I don't want to generalize this on everything. No. This is applicable to what? To which types? Primitive data types, the 8 types that we have seen, also strings, and strings. Okay, everyone? Okay? This is what we call pass by value. You are actually passing the value itself. Later on, when we deal with objects, we are going to learn about something called pass by reference, not by value. Okay? It is very similar if you remember in Python. If I pass a list, remember in Python, when I pass a list to a function, and then I change that list with that function, what happens? What happens to the list? If I go back, it changes. Remember that? Remember? Why? Because that's not passing by value, that's passing by reference. Alright? List is an object actually. So here you go. So we have already seen it here, but we didn't really learn the name for it. So far, passing by value, this applies to primitive data types and the string type. Here we go. Again, this is the stack for exactly what we did before. Modularizing code. Methods can be used to reduce redundant coding and enable code reuse. Methods can also be used to modularize code and improve the quality of the program. Remember the greatest common divisor example? Remember it? Remember it that we have seen before? Instead of having the code inside the main method, you can create a method for it, and then you can use it whenever you want. So here we go. So again, if you remember, so here we go. This is the main method, and then I created a method to calculate the greatest common divisor, GCD. The main method, just create a scalar class, ask the user for the values. Enter the first integer, enter the second integer, and then let the other method do the math. And this is exactly what happens, yani. This is something that reflects real life. Main method always interacts with the user, calls other methods. Doesn't do everything, yani. We usually don't let the main method do specific tasks. It's always about interaction and calling other methods. Like, so the greatest common divisor for N1 and N2 is, and here it is, GCD N1 N2. Alright, so GCD receives N1 and N2, returns an int. And then remember, this is the exact same code that we have seen before. It calculates the greatest common divisor and returns it. Okay. Remember this example? Remember it? Yeah, the greatest common divisor? We explained it in class. The same goes for the other example of a prime number method. This example I told you to, you need to study this example on your own. The example was printing the first 50 prime numbers from 1 till 50. Remember this. Alright, so again, instead of having the code inside the main method, you can just create a method for it and call it. This way, yeah, if I create another class and I want to call this method, GCD, how can I call it? How can I call it? Greatest common divisor method dot GCD. There we go. From another class. Fine. Case study, as usual, everyone. I told you, like, case studies are very useful in giving out examples about real life scenarios, giving you actual long code that you benefit from. Make sure to study every case study that you have in every chapter. Then we have overloading methods. What does this mean? What does overloading methods mean? We kinda know this because we use it, but now we know the name for it. What does it mean? Overloading methods meaning I can create multiple methods in the same class with the same name. How? The only condition here is that the parameter list is different. Yani I can have 10 max methods, all in the same class. No problem. As long as the parameter, not the return type, the parameter list is different. Why? Because most of the time when you choose a name for a method, let's go with max. This max returns the maximum of 2 double values. So what if you want to create another max method for 3 double values or for 2 int values? You don't want to give it another name. مثلا max int, no, خلاص, you want the name to be consistent. Okay? طيب. So that's exactly why we have overloading methods here, why we have this concept. طيب, which one is going to be called? The compiler is going to choose the method that is going to be called based on the arguments that you are passing. يعني, if you are passing 2 double, here you go, it will go to the max, to this max method. Okay? طيب. Let's look at an example and then we will see where we can have an issue. So here it is. There we go. I have this is my main method. How many max do I have? See? Max, max, and max. How many? 3. Max receives 2 int values. Max receives 2 double values. Max receives 3 double values. This is common. This is very common. And we see it also in the Java library. Let me show you. If I go to NetBeans very quickly. And I just wanted to show you a very simple example here. If I say مثلا system dot out dot so how many print methods do I have? You see how many? All of these are print methods. The same name. If I go to the system.out class in the Java library, I will see 1, 2, 3, 4, 5, 6, 7, 8, 9 print methods. So what is the difference? The difference is whatever they receive. The parameters. This one receives an object, the other one receives a string, the other one receives a boolean, etc. The same goes for printf. Here we go. I have 2 methods that is called printf. Println. All of these are println. So method overloading is always used, especially in the Java library. It is better. Why is better? So that naming is consistent. Don't create a new method with a new name when the task is the same. Fine. Let's go back to the example now. So here it is. Yeah. In my main method, system.out.println, the maximum of 3 and 4 is max 3 and 4. Which max is going to be called? The first one, second one, or third one? First one. Straight, see, and this is straightforward. 2 int values, I have this one receives 2 int, خلاص, done. طيب. It will return the, okay, here we go. Return now straight away. طيب, okay. The maximum of 3.0 and 5.4 is next. 3.0 and 5.4. Which one is going to be called? The second one. Here we go, the one that receives 2 double values. And finally, the maximum of these 3 numbers are, which one? Again? The third one, very good. And then if you see here, the third one uses the code for the second one. See what happens here? Inside the third one, it receives 3 double values, but then returns max of num1 and num2 and num3. What is max of num1 and num2? Which method is this? The second one. Here we go. Why? Why do I repeat the code? Why do I do if I have this code here? Why do I repeat it here for 3 numbers? I already have it here. So max of num1 and num2 is going to call this max method. This will return the maximum of either num1 and num2. Let's say num2. Then num2 and num3 will be passed to max again. So we'll call it again, and then at the end of the day we will have the maximum between these 3 numbers. فاهمينها؟ فاهمين اللي صار هنا؟ Yes, is it clear now here? Yeah? Ronnie, first row, quickly. Quickly and سريع. طيب. Can we have an issue here? Yes, we can. If the compiler gets confused about which method to call. The compiler gets confused about which method to call. This is what we call ambiguous invocation. So sometimes there may be 2 or more possible matches for an invocation of a method. But the compiler cannot determine the most specific match. This is referred to as ambiguous invocation. Ambiguous invocation calling, yeah? Invocation means calling. Ambiguous invocation is a compiler error. Meaning, you cannot run the code. What does this mean? Look at this example here. Well, I have max and I have another max. And then from the main method, system.out max 1 and 2. Now here, the compiler will not let us run the code. Why? Look at the first max method. The first max method receives what and what? Int and double. What the second one? Double and int. Type here 1 and 2. 1 and 2. 1 is int, so it matches this. 2 is int, and it can be casted automatically. This is implicit casting by Java to double. No problem, Java does it for us. Okay, so I can call this one. But also, here, 1 can be cast to a double straight away automatically by Java. They have nothing to do with it. And 2 is an int. So here we have 2 matches. In this case, you will see the compilation error, meaning it will not let us run the code at all. How can we fix this? You have to change the parameters. There's no other way around it here. You have to change the parameters. Aslan, why do you have this? And from a logical point of view, why are you creating 2 methods? One receives int and down and the other one double and int. What's the purpose? So here there is something wrong with your design, with the designing of the method itself. So how can we fix it? You need to change the parameters. Okay? Kamina? Alright everyone? So this is ambiguous invocation of all. Alright. We learned about scope of local variables before. What did I tell you about scope of local variables? Where? Inside what? The method?
The loop.
The loop. What do you call it? Inside what? Inside the block. Not that method, inside the block. If you create, if you declare a variable inside an if statement, it's only that if statement that can access it, not the entire method. Okay? Remember this, I told you. If you understand this, the scope, it will help us later on a lot. So scope of local variables. Number 1, what is a local variable? A variable defined inside a method. So any variable that's defined inside the method is called a local variable. Inside the method, regardless of where it's defined, it's called a local variable. Right, what does the word scope mean? The part of the program where the variable can be referenced. Used, changed, doesn't matter how you are using it. As long as you can reference it. Type in Java. Now remember, in Python, a local variable is accessible inside the entire method, not in a specific block. In Python, if you create a variable inside an if statement, you can still use it later on in a print statement outside if. Adi, we did this multiple times in Python. In Java, no. In Java, it's not the same. In Java, once you declare, I'm not talking about initialization, I'm not talking about assigning a value to the variable. I'm talking about declaration here. Once you specify the type, once you declare a variable, where is the scope? It starts from the line of the declaration and ends when the block is closed. That's it. This block can be if statement, else, a loop, the entire method, whatever. So the scope of a local variable starts from its declaration and continues to the end of the block that contains the variable. A local variable must be, of course, declared before it can be used. You can declare a local variable with the same name multiple times in different non-nesting blocks in a method. But you cannot declare a local variable twice in nested blocks. Look at this here. Type. Int I is 1. Here it is. Yeah. What is the scope for I? The scope, not the type. The scope. What is the scope? Where does it start? Here. The scope starts here. Type. Where does it end? Huh? I can't hear you. The loop. Very good. So this block. The variable was created here inside the loop. Khalas. Where does it end? It ends when the loop ends. Like what about int j? Where does the scope start? Start here, declaration. Where does it end? when the block is closed, this block, here we go. It is created here inside the loop block, so it starts from here till here. Once you are outside this block, خلاص, I and J do not exist anymore. They are actually removed from memory. They do not exist anymore. So a variable declared in the initial action part of a for loop header has its scope in the entire loop, but a variable declared inside the for loop body has its scope limited in the loop body from its declaration and to the end of the block that contains the variable. Now let's look at this example here. Right. Public static void method 1. Yeah. Int x is 1. What is the scope for x? What is the scope of x? The entire method, كلها. From here, from this line till the method is done, till this, the end of the method, which is here. What about y? The same thing, from this line till here. Type. Int I now, this int I. Where does it end, the scope? The first for loop, here. Type int I, this one, the second. That's why we can do this. This is fine. This is completely fine. Int I, why? Because this I and this I, they have nothing to do with each other. Completely separate values. This int I, this I is only accessible here. When you get to this point, خلاص, I does not exist anymore. The other I here is only accessible here. فاهمين علي؟ So when يعني after this point, every change that you make to I is you خلاص, you don't care even about it. You cannot even access it. So when you declare it again, it's as if you are declaring it. It's not as if you are actually declaring a new variable. طيب, look at this one here. Can I do this? I cannot do this. Int I is 1. Int sum واضحة. Sum from this line till the end of the method. Int I from this line till the end of this method. That means I cannot declare it, meaning create another variable with the same name. But I can say I, straight away. This means I am changing this I here. But I cannot redeclare it. Redeclaring meaning trying to create another variable with the same name. Alright, so this is wrong. Is the scope clear, everyone? The scope is clear? Very well. Type. Yeah. X, what is the scope of X? The entire method, correct method. From here till the end of the method, here. Y? The same thing. From this line till the end of the method. Type. I, this I here. The first for loop. This I here. And the second for loop. Type. Is this correct here? What's happening here? Very good. It declared X and then declared it here again. This is not correct. You cannot do this. Alright? You cannot redeclare. You can use it, you can use this X, change its value, use it, do whatever you want with it, but you cannot redeclare it again. Try to create a new variable with the same thing. Method abstraction. We talked about this in Python. What does this mean? Remember it? Black box. The method is a black box. Remember that? The content of the method body is a black box that contains the detailed implementation for the method. As long as we have the method signature, yani the name of the method, parameter list of the method, and we know the return type, خلاص. Do you really need to know about the implementation? No. Do you know what is the implementation of the println method in the library? No. What about the implementation of the scanner class? Do you know? No. There you go. But we use it. We use it. So, as long as we know that we have the signature of the method, the name of the method, and the parameter list, and we know the return type, and in which class it exists, so that we can actually call it, we are done. We can use it straight away without having to worry about the implementation. Benefits of methods, again, we are just repeating ourselves here. Write a method once, reuse it anywhere. Information hiding, we will learn about this inshallah later on, especially in object-oriented design. You can hide the implementation from the user. Yes, especially if you change the modifiers. Instead of public, leave it private. Type. And then it reduces complexity. Yes, instead of having one method do multiple tasks, this is what we have been doing so far with the main method. Now, خلاص, main method for interaction. What is the task? Finding the sum, create a method for that. Greatest common divisor, create a method for that. Calculate the area, create a method for that. Here we go. Reduce complexity so that methods have simple tasks. Just call them. طيب, again, another case study, generating random characters. The concept here is very clear. We use the math.random method, but to generate characters, not numbers. Not numbers. It's actually fun to look at this case study, so make sure to study it. Yeah, and here we go. Then we created a class from here, and then we can use this class anywhere we find it. Stepwise refinement. We learned about this in Python as well. Remember divide and conquer? Remember it in Python? When you have a system, basically when you have a problem that you're trying to solve, what do? You keep dividing it into smaller tasks, and then you get to the simplest form of these tasks, and then you create methods for each of the tasks. Here we go. This is it. This is what we call divide and conquer or stepwise refinement. So the concept of method abstraction can be applied to the process of developing programs. When writing a large program, you can use the divide and conquer strategy, also known as stepwise refinement, to decompose it into sub-problems. So you have your problem. Yeah, I'm trying to create a website, or I'm trying to create a program for students, whatever. There you go. Now divide it. Decompose it. So the sub-problems can further decompose into smaller, more manageable problems until you get to the simplest form of these tasks. What do you do then? You create methods for each of these simple tasks, and then your system will be a combination of all of these methods together. Let's look at this example here. We're going to apply stepwise refinement. This is a really nice example of a problem that is a real life problem. Look at this. Let us use the print character example to demonstrate stepwise refinement approach. What do we do here? We ask the user to enter the year, and then the month in numbers from 1 to 12, so the number of the month. And if they want January, they put 1, for example. What do? We print the calendar of that month. Yeah? This is not an easy problem. This is not an easy problem. We print the calendar of that month in that year. Right. Let's look at the code. The code is long, of course, obviously. Print calendar. Look at this. Nice. Yeah? There you go. This is a very nice example of a program. I have my main method. How many methods do I have? I have print month, print month title, get month, print month body, get start date, get total number of days, get number of days in a month, is leap year. All of these are methods in this type. I'm going to go over it very quickly. So I put the scanner class, created my scanner, I asked the user, yalla, enter the full year. I stored in year, enter the month in numbers, I stored in month. Then, that's it, see? The main method ends here. Print month, year, and month. Go to print month. Print month receives it, calls first print month title, the title. There you go, print month title. Uses another method to get the name of the month, get month name. What is get month name? Here it is. It uses switch case. If the user says 1, it's January. If it's 2, it's February. Returns the name of the month. Go back here. There you go. So the name of the month is returned here. Type. Print the year, print this, and print here we go. This is the header. Type. Now what? Go back here. Print month body now. Yeah, print month body. We go now. Print month body. Print month body. Calls get start day first. Get start day, where is it? This is get start day. Received year and month. Get start day, What does get start day do? Specifies this the day on which the month starts. Is it Sunday, Monday, Tuesday? Which day does it start on? Right? Here we have a formula that we are using. Now, get total number, and then it uses another method, get total number of days, get total number of days in a month. Yeah? Get total number of days based on the year. So here it also uses is leap year. Is leap year, here it is, where is it? It's down here. This is leap year. Remember the formula for is leap year? Is leap, remember it? To know whether the year is leap or not? Then go back here. If it is leap year, this means that we have 366 days, otherwise it's 365 days. And then depending on that, you can calculate the get number of days in a month, get number of days in a month, here we go. If it's January, if it's March, if it's May, it's 31, otherwise it's 30. Otherwise, if it's February, then we need to check if the year is leap or not. What is this yet? Conditional operator. اللي حاطين لي logical operators or XOR with the mean, yeah, ولا relational operators greater than is that. كل ما واحد يقول لي أنا عارف إيش هو حط لي OR ولا XOR. XOR هذه مشهورة كانت في الكبار. This is conditional operators. طيب, go back. And then get the total number of days, and finally return this, and finally print it. What is the print statement? But even I'm lost. Now I'm lost. Here we go. Yes, here it is. Here it is. Return this, goes back here, and then here we go. Add pad spaces, and based on the start day and everything that we calculated so far, we print it. Fine. This is not an easy task. Of course not. Of course, this is a long, complicated program. Yes, very useful. Yes, but as long as it's complicated. How are we going? How did we do this? How did we create this program? Here it is. This is the design diagram. So, the main method, this is called the print calendar. The main method, what does it do? The main method calls print, reads the input, and calls print month. Type. The print month method calls print month title and print month month. The print month title calls get month name. This one calls get start day and get number of days in month. And then here we go. This one calls this one as well, and this one again. And both of them call is leap year. Type. Now, you see these methods, all of them together, constitute the system that accomplish this task. Like, how do we do this? You can do it either from top down or from bottom up. Alright? And both approaches are valid. Like, if you start from the top, so top down approach is to implement one method in the structure chart at a time from the top to the bottom. So you start with the main method. But I still don't know the implementation of the rest, because this one calls this and this one calls that. What do? You use stubs. What's a stub? Stubs can be used for the methods waiting to be implemented. A stub is a simple but incomplete version of a method, basically a method with an empty body. That's it, yeah. The use of stubs enables you to test and invoke the method from a caller. Implement the main method first, and then use a stub for print month method. For example, let it display the year and the month, and that's it. Okay? So this is top down. Type bottom up, likes. Bottom up, you start with the simplest form of methods, and then you go your way up. So bottom up approach is to implement one method in the structure chart at a time from the bottom to the top. For each method implemented, write a test program to test it. Both approaches are fine. They implement the methods incrementally, and they help to isolate programming errors and makes also debugging easy. Sometimes they can be used together. Real life scenario, well, in the industry, especially when you are working in the team, these kind of protocols of how you are developing a system are decided by, not by the team, but by management itself. Okay? So they tell you how to do it, either top down or bottom up. But again, both approaches are valid. Benefits of stepwise refinement. Why do we do this? Simpler program. Yes. The simpler the task, The simpler the method, the simpler the program. There you go. Reusing methods. When the method is very simple, like SDP. SDP is very simple, it's one line, just checking. You can use it in 100 systems, no problem. You can use it over and over and over again. Easier developing, debugging, and testing, yes. Again, the simpler the method, the easier the developing, and also the testing for the method. And of course, better facilitating teamwork. You can divide the tasks between team members easily using stepwise refinement. Questions? Someone you'll record. Questions? انتم نعسانين صح؟ نعسانين. بدي بس تسلكوا كذا صح؟ عندكم اختبارات الاسبوع هذا؟ غير اللاب؟ طبعا. والحين نايمين واخر شيء اختبار صعب. صح you did not ask. يلا show of hands. You can stop. يلا show of hands everyone. Who thinks